Picture this. You're cruising along at 35,000 feet. Everything's calm, it's just another flight. And then, in an instant, it's not. Up in the cockpit, a sudden, critical event has just kicked off one of the most intense maneuvers in all of aviation, the emergency descent. Let's get into what that really is. And that's the sound. A loud, sharp bang. For the pilots, the world has just completely changed. A master warning light is flashing red, a piercing alarm is screaming, and an alert pops up showing the cabin altitude is just climbing, fast. The air gets thin, you might even see fog form in the cabin. In a split second, the mission changes to one thing and one thing only. Get down now. Now, it's easy to imagine this as some kind of out-of-control freefall, but it's actually the exact opposite. This is a deliberate, highly practiced safety procedure. Don't get me wrong, it feels violent, but every single action is calculated, it's precise, and it's all designed to get the aircraft from a very dangerous altitude to a safe one, as fast as humanly and mechanically possible. So what are the pilots actually seeing in those first few critical seconds? Well, it's a flood of information. That master warning is the big red flag telling them something is seriously wrong. And right alongside it, they're watching the cabin altitude indicator just spinning upwards, 10,000, 11,000, 14,000 feet. That means the pressurized bubble keeping everyone safe and comfortable has just burst. The clock is officially ticking. That incredibly urgent scenario is what forces the maneuver we're talking about today. So let's pull back from the cockpit drama for a second and just get a really clear, basic understanding of what an emergency descent actually is. The official definition is pretty simple, right? But the real story is in the numbers. See, a normal, comfortable descent for passengers is maybe 2,000 feet per minute. An emergency descent? Forget comfort. We're talking a no-holds-barred plunge where survival is the only thing that matters. So why would a pilot ever have to do something this drastic? Well, the list of reasons is short, but every single one of them is incredibly serious. Let's look at what could possibly trigger this kind of dive. Interestingly, the triggers can be a bit different depending on the plane. For a big airliner flying way up high, the number one concern is a rapid decompression, basically a hole in the airplane. Could be from a structural failure, anything that breaches that pressurized cabin. But for smaller aircraft that aren't pressurized, a major trigger is an uncontrollable fire or thick smoke in the cockpit. The goal there is simple: get on the ground as fast as you possibly can. Okay, now here's what's so fascinating about all this. This is not a moment of panic. It's not improvisation. It's the instant execution of what pilots call a memory item. These are emergency procedures that are so important, so time-critical, that pilots have to know them by heart. No time to grab a checklist. They have to act now. And that memorized response is broken down into 4 clear stages. Number 1, always, is fly the airplane. Then set it up for the fastest descent possible. Third, you've got to tell the world you're in trouble. And finally, you monitor the whole thing and prepare for a safe recovery. Let's break each of these down. The very first actions are pure muscle memory. Masks on, immediately. This is to fight off hypoxia, a lack of oxygen that can wreck your decision-making in seconds. With masks on, the pilot flying immediately banks the aircraft and pitches the nose down, starting the dive. This isn't just pointing the plane at the ground. It's a very specific, controlled maneuver. But wait, why the turn? This is such a brilliant, built-in safety feature. By banking the plane, the pilots can actually see the airspace they're about to dive into. The absolute last thing you want in an emergency is to cause another one by colliding with a plane that was flying on the same route thousands of feet below you. Next up, the pilots have to turn this sleek aerodynamic jet into something more like a brick. The engines go to idle power. They pop out the speed brakes, panels on the wings that create a ton of drag. And they push the plane right up to its maximum safe speed. It's this incredible balancing act, getting down as fast as possible without pushing the airframe past its limits. And here's the result of all that. The descent rate can be staggering, sometimes over 10,000 feet per minute. To put that in perspective, that's like descending the entire height of the Empire State Building every 8 seconds. You can imagine the feeling inside. A loud roar of wind, heavy vibrations. Your ears are definitely popping. So while they're managing this high-speed dive, the pilots have to communicate. They'll switch their transponder to a special code, 7700. This is the universal signal for an emergency. It instantly lights up air traffic control screens, telling every controller that this plane is in serious trouble. Right after that, you'll hear the Mayday, Mayday, Mayday call over the radio, clearing a path for them. So what's the finish line for this plunge? Where are they heading? The primary target is almost always 10,000 feet. Why? Because that's the magic number. It's considered the highest altitude where you can breathe normally without needing supplemental oxygen. Once they hit 10,000 feet, the immediate threat of hypoxia is over. Okay, so after that incredibly intense dive, the hard part's over, right? Well, not exactly. The maneuver isn't finished. Let's look at what happens in the recovery phase after the plunge is complete. So, the plane is now out of the immediate danger zone, cruising along at 10,000 feet. The dive is done. What's the game plan now? The recovery is just as methodical as the descent itself. The pilots smoothly level the aircraft off. They pull in the speed brakes and bring the speed back to normal. And now, for the first time, they can really take a breath, assess the damage, figure out what went wrong, and make that crucial decision. Where is the closest, safest airport to land this airplane? This quote just sums it all up perfectly. To anyone on board, it feels and sounds absolutely terrifying. But from the pilot's seat, it's a powerful demonstration of training. Every single action, maximizing drag, watching the speed, turning to check for traffic, it's all part of a life-saving playbook. It's controlled chaos with one very clear goal. So the next time you hear a news story about a plane making a rapid descent, what will you think? Will you picture an uncontrolled fall? Or will you picture a highly skilled crew using a powerful, practice tool, a violent but vital lifeline, to pull everyone back from the brink and get them safely toward the ground?